Welcome to this video. In this video, we will discuss a trapezoidal rule for performing numerical integration. So first of all, we will understand what is trapezoidal rule. So basically, a numerical integration means instead of having an analytical method, we use integrating a function by a formula, by a function. Instead of using an analytical function, we use Newton's forward differential formula or Newton's quadrature formula, and then we use numerical methods, data, instead of analytical formulas. So that is what a numerical integration means. So we'll have a data set, and the data set will be used for integration. So we divide the data set into equal intervals having equal width, and then we integrate from the starting data set to the last data set in equal steps. And the function we use to approximate the data set is what we call as Newton's quadrature formula. So here you can see here the function which is called as Newton's forward differential formula, which means if you have a data set, then you can approximate the data set into a formula, a function which is given by fx is equal to y0 plus p into delta y0 plus p into p minus 1 by 2 factorial delta square y0 plus etc. So as it is just like a GP, where you can see after every term you will having terms of p into p minus 1, p minus 2 as it goes on increasing, and the denominator, the factorial, is also increasing. So 3 factorial will come, and after that 4 factorial will come, and the derivative is also increasing. So the delta cube refers to the third difference, delta square y0 refers to the second difference. And if you use this Newton forward differential formula and you assume the data set is equidistant in terms of x, and use the condition that xn is equal to x0 plus nh, then this equation or this function will become Newton quadrature formula. So which is nothing but the integral. The integral value is given by Newton quadrature formula, which is the integral is nh into y0 plus n by 2 delta y0 plus n into 2n minus 3 by 3 factorial into delta square y0 plus etc. So this is what the integral. And now the value of n will change from 1, 2, 3, etc. So if you assume that n equal to 1, that results in trapezoidal rule. That means you assume that each step of x will provide a trapezoid, and the area of the trapezoid is known, and then you add the areas of all trapezoids. That will give you the sum of areas. So the function will become, that means the Newton quadrature formula will become the sum of the areas will be h into y0 plus, I am putting n is equal to 1, so that will become h into y0 plus n is 1, so that will be 1 by 2 delta y0, h into y0 plus delta y0 means nothing but y1 minus y0. So the answer will be h by 2 into y0 plus y1. So this is for the first x interval. Similarly, for the second x interval, that means from x0 plus h to x0 plus 2h, the same thing we will do, and instead of y0, y1 will come, and instead of y1, y2 will come. So if you do repeat this process and reach up to the last trapezoid, that will become the total areas will be h by 2 into y0 plus 2 into y1 plus y2 plus etc. plus yn minus 1 plus yn. So yn is the last value of y corresponding to the xn. y0 is the first value of y corresponding to the x0. So this is what we call as trapezoidal formula. So the area under this curve is shown in this figure. You can see this is a function. So basically the integral of a function is nothing but the area under the curve of that function. So we are doing this by dividing the area under the curve into trapezoids, and adding the area of trapezoids will give you the area of the total function or the area under the curve. So we can do this by using a Python program which is given by So this is a program. So we have start from math import star. I am going to integrate sin x. So I am defining a function which is sin x, and then from which limit, lower limit, I have to integrate. I am inputting. I am using the input function. I am storing that value, and the upper limit of the integration is also stored using the input function. And the number of intervals of this x interval is also input in the input function by using the input function. And we divide the x interval into n parts, and width of each is calculated is b minus a by n. And then I find the first and the last value of the function, because that corresponds to y0 and yn. So that will be f of a plus f of b, and then I am going to find the trapezoidal rule formula, which is integral plus 2 times f of x in between the first and the last values. So again I multiply by h by 2, and then I print the value of the integral that will be given by the intgl. So that will give you. So let us run this program. So lower limit is 0, upper limit is pi, number of intervals I'm putting 100. So the integral is 2. So it is correct. So sin x, if I integrate it, and then the limit is 0 to pi, that is 2. So I'm getting 1.999. So we got the correct answer.